Let's talk about some more three-dimensional shapes, starting with the cylinder. A cylinder is made up of two congruent parallel bases, just like the prism was, but those parallel bases are not polygons. And the bases are connected to each other with a curved surface that is defined by the edges of those non-polygonal bases. So the picture that you're seeing is probably what you think of when you think of the word cylinder. We usually think of something that's kind of shaped like a can. Well, that's an example of something called a right circular cylinder. It's circular because the bases are circles, and it's a right circular cylinder because the two bases are directly aligned with each other. If you look at that line segment that goes from the center of one base to the center of the other base, the line segment that goes from the centers of each circles, connects those up. That line segment is perpendicular to both of the bases. So that's where this gets the name right circular cylinder. This, on the other hand, is also a cylinder. It has those two congruent parallel non-polygonal bases, and they're still connected with this curved surface, but those two bases are not aligned with each other in the same way. So this is called an oblique circular cylinder. In fact, those two bases, as long as they are not polygons and they are congruent to each other and parallel, we still are going to have a cylinder, which means even something like this would be considered a cylinder. It has two congruent bases. They are parallel to each other, and they are connected with that smooth surface. So we can have some rather strange looking three-dimensional shapes that we could still call cylinders. We're going to focus on the right circular cylinder in the problems that we do. The other shape we're going to talk about is the cone. Now this is probably what you think of when you think of a cone, because we think of something maybe like an ice cream cone. Well, what makes this a cone is that it has one base that's not a polygon, and it has a point that's not contained in the plane of that base. Now that point is what we call the vertex, and the point is connected to the base by a smooth surface that connects the point to the edge of the base. This one is called a right circular cone. It's circular because the base is a circle, and it's a right cone because that vertex is immediately above the center of the circle. So if you look at the line segment that connects the vertex with the center of the circle, it's at a right angle to the base. Now, just like with the cylinder, we can take this cone and kind of shove it off to one side. We still have a cone, but now we have an oblique circular cone. Oblique just means kind of pushed aside, askew. Now we talked about volume with prisms and with pyramids. Volume is something we can also find for cylinders and cones, and it means the same thing. It's still the amount of three-dimensional space occupied by an object, and it's measured in cubic units. And if we have something like this rectangular prism, it's pretty easy to see how to fill it up with cubes. But we can still think of the amount of space inside of these shapes that have kind of curved sides. And what we'll still be looking for is the number of cubic units inside the shapes. So let's look at some volume formulas. And we're going to compare the two formulas that we've already found for prisms and for pyramids. We're going to compare those to the formulas that we'll be using for cylinders and cones. So starting with prisms, what we said with prisms was that if we think about the shape of the base of a prism and we find the area of that base, so in this case we'd have 6 square units of area, We can then think about what happens if we start to create something that has a volume by stacking some layers on top of it. So in this case, we have a shape that has 6 square units of base area and a height of 2. So to find its volume, we would simply take that base area of 6 times its height of 2 to get a volume of 12 cubic units. Now that same idea can be applied to cylinders. If we think about the base of a cylinder, and we're going to confine ourselves to just talking about circular cylinders. So we have a base that's a circle. We could certainly find the area of that base. We know how to do that. The area of a circle is pi r squared. Now imagine that we take that base and we start to stack layers on top of it. So if we multiply the area of the base times the height of all those layers, we'll still have the volume. Which means for cylinders, the formula for finding the volume of a cylinder is identical to the formula for finding the volume of a prism. It's still the base area times the height. And remember, if the base is a circle, we could even say that the volume is pi r squared, because that's the area of the circle, times the height of the cylinder. Now we also talked about pyramids before, and we said there was an interesting relationship between the volume of a pyramid and the volume of a prism. And what we saw was that if we have a pyramid, we can take 3 of those pyramids and put them inside one prism that has the same base and the same height as the pyramid does. So that led us to our formula for volume of a pyramid, which was that volume is 1/3 of the base area times the height. Now if you think about cones, cones have something in common with pyramids. They have a base, but then from that base they extend upward to a point. So because of that, cones have the same relationship to cylinders that pyramids have to prisms, which is that the volume of a cone is 1/3 of its base area times its height. In other words, we could fit 3 cones inside of one cylinder that has the same base and the same height as the cone. So let's practice this a little bit. Let's say we want to find the volume of this cylinder. We know that the base is a circle and it has a radius of 2 centimeters. We know that the height is 5 centimeters. And we know that in order to find the volume, all we have to do is take the area of the base times the height. So the area of the base is pi r squared, so that's pi times 2 squared, times the height, which is 5. And we end up with a volume of 20 pi cubic centimeters. Remember, volume is measured in cubic units. Let's find the volume of this cone. Now we said that to find the volume of a cone, we still need the base area times the height, but we'll have 1/3 of that base area times the height. Now the base is still a circle. It has a radius of 12. So the area of the circle will be pi times 12 squared. The height will be 20, and we need 1/3 of that, which will give us a volume of 2,880 thirds pi cubic units. Now we've also talked about surface area, and we said that surface area is nothing more than the total area of the skin that fits around a three-dimensional shape. And if we can think of the shape of that skin, which we called a net, if we can think of the net for that three-dimensional shape and find all of the areas of all the pieces of the net, we'll have the surface area of the three-dimensional figure. Now take a careful look at this picture. Right now we're talking about Cylinders and cones. Can you look at this picture and figure out which nets would have to be the nets for a cylinder and a cone? Focus on the orange ones. The orange ones are the ones we're going to work with right now. The orange one you see on the left is the net for a cylinder, and the orange net that you see on the right is the net for a cone. So let's start with a cylinder. Now here's what we need to think about with a cylinder. If we want to look at the net, we want to look at the outside part, we have to imagine that we cut this open and we lay all these parts out flat. And obviously the circles on the ends are already flat, but this curvy side is not flat to begin with. So we're going to take this cylinder and just slice that curved side vertically between the two circles, and then spread it out flat, and we'll have something that looks like this. Now think about the two shapes, or three shapes we actually have. We have two circles and we have one rectangle. The circles we already know how to find the area of. We know the area of a circle is pi times its radius squared. So we have two circles, so we're going to have two of those areas that are pi times the radius squared. We also know how to find the area of a rectangle. We know that's just its length times its width, but we need to figure out what those dimensions are. If you look back at the picture of the cylinder, you can see that the height of the can is actually this dimension, this vertical dimension we see in our picture. But we still need to find this dimension, that horizontal dimension on the rectangle. Now imagine where that came from. That part of this cylinder was originally wrapped around the outside of this circle, which means that that side of the rectangle has to have the same length as the circumference of the circle. And the circumference of a circle we can find by taking 2 times pi times the radius of the circle. If we multiply those two dimensions together, we'll get the area of the rectangle, which would have to be 2 pi r times h. So now we have everything we need for a formula. If we take the two circles areas and add those together, plus the area of the rectangle, we'll have the total surface area of this cylinder. Now how about a cone? We still want to look at the surfaces, so we want to imagine slicing this open and laying it flat. The circle is already flat, but it's that curved side that we're going to have to do something with to flatten it out. So we would have to slice this along that, maybe along that yellow line segment you see, and then flatten it open, and we'd have something like this. Now that yellow line segment's really important because it's called the slant height, and we're going to need to find the slant height to find the area of that sector of the circle that's making up the side of our cone. The circle part, we can find its area by just taking pi times the radius squared. But the part of the circle that goes around the side of the cone, we're going to find by taking pi times the radius of the circle times L, where L means slant height. Now look back at that picture of the cone, because this is a really important point. The slant height is measured from the vertex of the cone, which in this picture is at the bottom, along the side of the cone to the edge of the circle. If you look in the picture, there's also something that's labeled H. H is the height of the cone. That's the distance inside the cone from that vertex to the center of the circle. H is something we'd need to know if we were finding the volume of the cone, how much the inside of the cone holds. But if we want to know the surface area of the cone, the measurement we need to have is the lateral height, the slant height, which is along the outside of the cone. That's that yellow line segment. So if we take the area of the circle, pi r squared, plus the area of the part of the circle or part of a circle that goes around the outside of the cone, pi r L, we will have the total surface area for this cone. Now let's see if we can use that surface area formula for a cone, because sometimes there's an extra step we have to do if we haven't been given all the information we need for the formula. So we want to find the surface area of this right circular cone. And we know that to do that, we need to take pi times the radius squared plus pi times the radius times the lateral height, the slant height. Well, the radius is given to us. That's the 5. But look carefully at the 12. The 12 is not the lateral height. The 12 is the height of the cone. If we wanted to find the volume, the 12 is what we'd need. Now, if you'll notice, that lateral height is part of a right triangle. And if we have 2 of the 3 measures of the sides of a right triangle, we can always find the third. So we can use the Pythagorean theorem to figure out what L is, because we know that L squared has to be 5 squared plus 12 squared, which means L, the slant height, the lateral height, is 13. So now we have everything we need, because to find the surface area, we need pi times the radius of that circular base squared, so pi times 5 squared, plus pi times that 5, that's the radius, times the slant height, which is 13, which gives us a surface area of 90 pi square centimeters. Remember, we're measuring an area this time, so our unit of measurement has to be in square units. Now, some of these problems are a little tricky because they're kind of involved. There's a lot of computation we have to do. So you have to be very careful as you're working through the problems. You're going to get a chance to practice more of these in class.